When you have to design an attainment plan, you need key tools. States are very familiar with these tools, and they work hand in hand with EPA as these tools are developed. But the principal tools are things we've discussed earlier. Monitoring. You need to have a monitoring network out there, and you have to be able to collect ambient air quality data. That's the only way you can set a design value to know whether an area is attainment or non-attainment, and it's the only way you can measure improvements in air quality to see if all of your good air quality planning works. Emission inventories, as we discussed earlier, emission inventories are a compilation of emissions data from sources or source categories of the criteria pollutant or the criteria pollutants precursors. Most of you know ozone isn't directly emitted from a chimney, stack, vent, or tailpipe. It forms in the atmosphere in the presence of VOC and nitrogen oxides with sunlight and warm temperatures. That's why ozone tends to be a summertime problem. And the other important tool is the modeling, as we've discussed before. I'm going to talk a little bit more about each of these tools, but there will be other presenters at EPA who will give you an even better flavor for these things. Ambient air quality monitoring. You need an approved network and approved equipment. The approved equipment can be referred to as a reference or equivalent monitor and methods. So sometimes you hear people talk about FRMs, federal reference methods, or federally equivalent methods. As a matter of fact, in the ozone world, we can find up to as much as 90% of the monitoring being done with equivalent methodologies. All of the data that is collected has to be quality assured and controlled, and then it's certified. That data has to be put into AQS, the air quality system, and specifically that data, until and unless it is in there and has been flagged, is not eligible to be used in regulatory decision making. In other words, until the data is collected, it's been quality controlled and assured, it's been certified, and it's in the national database. Only then is that data available for use in regulatory decision making. Ambient air quality data should not be confused with in-stack data that is recorded by a continuous emission monitoring system or a continuous opacity monitoring system. In other words, you also have monitors that can be put in a stack or in line with an industrial process such that you're directly measuring the emissions from that stack or industrial process in terms of either emissions or its opacity readings. But those type of monitors are not ambient air quality monitors. Those are generally called in-stack monitors. Emission inventories. Stationary sources, those are sometimes called point sources. This is basically the industrial sources out there of the criteria air pollutant or its precursors. So in other words, if you were designing an ozone SIP, you would find NOx sources and sources of volatile organic compounds. For PM 2.5, you're looking at sources of particulate matter, sources of nitrogen oxides, and sources of sulfur dioxide, because those are precursors of PM. Mobile sources, on-road. The emission inventory for mobile sources makes a differentiation between mobile emissions from on-road sources, think vehicles, the things you see on the road, and mobile sources off-road, which can be, for example, construction equipment, all of the mobile activity that occurs at a large airport is another example. You can find, if you've ever visited a very large steel facility with coke oven batteries or a very large paper mill, they have many roads and they have a lot of construction equipment and mobile equipment, and those are called off-road mobile sources. Area sources. Now, area sources are interesting. Area sources can be us. In other words, if you want to strip furniture and you go out in the driveway and you bring the furniture out there and you start to use something with a lot of solvents and VOCs in it, you are an area source. You're putting volatile organic compounds in the air. You guys who like to detail the cars, the paints for detailing tend to have a high VOC content in them. But area sources, in addition to meaning sources of a pollutant that are not mobile but are too small to be considered a point source or a stationary source, in addition to those being area sources, an area source can also be something like painting a major bridge. In Philadelphia, there's a nice big Ben Franklin Bridge between Philadelphia and Camden, New Jersey. They're painting that bridge right now. And that bridge, while it's being painted, is an area source. Now, biogenic sources are non-anthropogenic emissions. Biogenic are naturally occurring sources of air pollution. One of the most common ones to think about is isoprenes from pine trees. They're among the most reactive VOCs out there. By reactive, we mean they're the type of VOC with a very high tendency to form ozone under the right meteorological conditions and with nitrogen oxides in the air. I want to say right away, no one is suggesting as control strategies that we chop down any pine tree forests, but you have to account for those biogenic emissions in the air. And remember, when you're doing emission inventories of point sources, mobile on-road, mobile off-road, area sources, and biogenics, sometimes you're measuring the pollutant directly, but don't forget if that criteria pollutant has precursors. What you're trying to accomplish during the SIP planning process you are trying to find out with the greatest degree of accuracy possible what were the emissions in the air during that 3-year period that we used to set the area's design value, to calculate it. So we monitored an area and we looked at 3 years worth of QA, QC data and over that 3-year period, and we determined its design value. And that design value is higher than the National Ambient Air Quality Standard, meaning the air quality is worse than the standard. In order to have any hope of being able to plan to get the air quality back to attainment, you need to know what was in the air during that time you monitored that resulted in those readings. And you have to do it for point sources, mobile on-road, mobile off-road, area sources, and biogenics. You want to try to do it as carefully as possible, because if you underestimate or overestimate the emissions, it can throw off your ability to determine what will be the effect of controlling certain source categories. Modeling. For many of us, we discuss whether this is a science or an art. I tend to say it's both. Air quality planning models you have to deal with the domain and you have to deal with transport. By the domain, we mean the geographical area always larger than the non-attainment area itself when it comes to air quality planning. The domain is the gridded geographical area over which you are going to produce a modeled attainment demonstration. These air quality planning models, not only do you input the emission inventory information from within the non-attainment area, the emission inventories that we just talked about that are developed, the meteorological data that's a snapshot that goes into the planning models, but you also have to account for transport. Now, the most recent EPA-approved models to be used in air quality planning do have elements that account for transport. There are always arguments whether they sufficiently address transport at all levels. Currently, there are folks who believe that transport is captured pretty well at ground level, but certain high loft transport may not always be accounted for in the modeling. It's something EPA continues to work on with states and with major universities across the country. Our models tend to be developed by academia and then worked upon with other people from perhaps consulting firms, engineering firms, and within EPA. But the modeling community works closely together from all sectors of society. There's something also called emission inventory models. You will recall that I talked about the fact that we have to emission inventory mobile sources. Well, point sources, we actually get the emission inventory information from the sources themselves. States send out, or now electronically send out, forms that sources fill out, which would enable the state to calculate what the emission from a stationary source would be. For area sources, we tend to use population data, and some other data to come up with area source emissions. But for mobile emissions, we use models. For years, we've used mobile 1 through 6. But now we've moved to a new mobile model called MOVES. But just to be clear, MOVES is not an air quality planning model. MOVES is an emission inventory model where you input information about vehicles, vehicle miles traveled, and other parameters, and the model will give you the emission inventories for on-road and off-road mobile sources. Air quality modeling requires the expertise of atmospheric physicists or meteorologists with on-the-job experience. I always say this, do not try this at home. You can work with people who have expertise in this field and listen to them, and you can maybe be tempted at times based upon what you've heard to render some judgments in a case about what model should be used, what that model input should be. If it's not your job and you don't have a lot of experience in it, don't do that. Leave this one to the experts. Now, as I said, most of the people who are considered air quality modelers, the most common degree is a degree in meteorology. Some folks hold degrees in atmospheric physics, particularly particle science. Some people have degrees in mathematics, and with a lot of OTJ, on-the-job experience, they become modelers. People can become modelers if it is their full-time job, but again, it is not something that one dabbles in. Leave this one to the experts. EPA has approved models and guidance. The other thing that's necessary before an air quality model can be used to do attainment area planning is something called model evaluation. Model evaluation is an evaluation of that air quality planning model to see if it works in that geographical area. And so you might say, well, how would that happen? How would you do a model evaluation? The way it's done is quite interesting. You pick a historical non-attainment episode, and what you do is you obviously have the actual ambient air quality data that was recorded during, say, a 3 or 4 day episode of where the air was non-attainment historically. What you do with the model is you take the same, you try to get the same emissions that were actually in the air at that time and the historical meteorological data, and then you run the model, and then you plot the model's results against the actual ambient air quality data that was monitored, and you track the model's performance. How close did it track what was actually being recorded in the air? Now again, the EPA guidance for this provides for error bands and within certain differences can be accounted for, and the model can still be used. But model evaluation is important because that's how you figure out whether that model will work in that given geographical area. For model projections, you input the emissions that would be in the air after the state adopts the control strategies and regulations to reduce air pollution from certain sources and source categories. You put that new inventory information, that projected inventory, in other words, what will the emissions be after these regulations and control strategies take effect, and the model will then project what the air quality should be. When it's done, when a state has adopted enough control strategies in combination with federal measures such that the model demonstrates attainment. In other words, that domain that I talked about, that geographical area that was broken up into grids, okay, the model shows that with the reductions that have been adopted by the state, approved into the SIP, in combination with federal reduction measures, will produce an attainment demonstration. In other words, the model shows that every grid cell is popped green. That's a term of art we use, meaning that you got a very good attainment demonstration. The model shows that every grid cell within the domain has air quality. It projects air quality below the National Ambient Air Quality Standard. ozone has proven to be a pretty intractable problem for us. There is a belief many times that our models tend to over-predict the problem, or in other words, under-predict the benefit of some of the control strategies. So some attainment demonstrations go to what's called weight of evidence. Weight of evidence is usually done in a situation where the modeling demonstration was unable to project attainment in every grid cell. But because of the tendency to believe that the model may not be properly accounting for the benefits from certain reduction strategies, states will go to what's called weight of evidence. And EPA provides guidance to do this. In this case, with a weight of evidence determination, it's a combination of modeling and actual recent monitoring data to determine whether or not you believe you have produced an attainment demonstration. Weight of evidence is, again, a very technical exercise. The review of a weight of evidence demonstrations are designed by modelers, and they're evaluated by modelers. The attainment plan. Now, we talked about what has to be in the attainment plan. In other words, here is the big SIP that was due to EPA for a given non-attainment area 3 years after the area was designated non-attainment. What are the elements in that attainment plan? Well, we've talked about some of them earlier. The infrastructure requirements at 110, 1 and 2A through M. Remember, we talked about, in other words, what does the state agency or the agency responsible for the SIP have to have the authority to do and has to have the resources to do in order for it to qualify under the Clean Air Act as an agency with the capability of and the authority to produce an attainment plan. So one thing that's in the attainment plan is you check the box to say, yes, the SIP has all the 110, 1 and 2A through M requirements. The other thing we talked about earlier is that Part D of the Clean Air Act is where you find the requirements for non-attainment areas for a given pollutant. Some of the Part D requirements could involve reasonably available control measures, which can include reasonably available control technology on existing stationary sources, state mobile and area programs. It can also include some of the federal requirements, and a new source review permitting program. In other words, in this case, a new source review permitting program for major stationary sources and major modifications of that pollutant who want to locate in the non-attainment area. You also have to have a minor source permitting program as part of an attainment plan. The attainment plan can also take credit for federal mobile measures and fuel measures, as well as federal area source measures. Now, what we mean by this is, as most of you know, there are federal requirements for tailpipe standards for cars, improved engines in cars that reduce pollution. There are fuel requirements. For example, there's a program that lowered the Reid vapor pressure in gasoline called the low RVP programs. There was also the reformulated gasoline program. These are federal measures. They're not state measures, but because they will produce reductions, where these federal mobile and fuel measures occur after the base year, in other words, that first set year when we were taking a look at the design value that designated the area as non-attainment in the first place, where these federal mobile measures kick in and fuel measures kick in, the states can take credit for that in the state implementation plan and can include those reductions in the modeling so that those benefits should show up to see if you've produced an attainment demonstration. There are also federal area source measures. I'll give you an example. I mentioned something like painting a bridge, okay? We have what are called the architectural and industrial maintenance coatings. That is just one example. There's another federal area source requirement for consumer products. We have them for things like gasoline cans that people keep in the back of their cars. These are federal area source measures. There's a series of them. States can take credit for the federal area source measures that EPA requires across the whole country. The other thing that must be in an attainment plan are contingency measures. And we're going to talk a little bit more about contingency measures later on, but basically what it means is what, in addition to the state and federal control strategies and measures that would reduce a criteria pollutant and its precursor emissions to produce an attainment demonstration, these are some additional measures that would be able to be in place should the area need these additional reductions to achieve attainment. Part D requirements. The Clean Air Act mandated requirements for designated non-attainment areas. Usually Part D requirements increase in number and stringency depending upon the classification of a designated non-attainment area. In other words, the more severe the non-attainment area, the higher its classification may be. For example, you could have an area designated non-attainment for ozone, and it may be a moderate area, where another area non-attainment for ozone could be a serious or a severe area. Basically, the Part D requirements tend to increase in number and stringency depending upon how severe the non-attainment problem is in a given area. When it comes to Part D requirements under the Clean Air Act, those are the SIP revisions that if a state fails to submit or gets a finding of incompleteness or gets a disapproval, for those types of Part D SIP elements, that's what would commence sanction and FIP clocks. Control strategy SIPs. Rate of progress plans and attainment demonstrations and maintenance plans are all control strategy SIPs. And they take into account the credible emission reductions necessary to demonstrate rate of progress or to demonstrate attainment or to demonstrate maintenance. So the three kinds of control strategy SIPs are the attainment demonstration, that model demonstration, which may involve weight of evidence, that took into account the reductions in a pollutant and its precursors to produce an attainment demonstration. Remember, a rate of progress plan was, or a reasonable further progress plan as they're sometimes called, shows an annual reduction in emissions of the criteria pollutant or its precursors until the attainment date. Or if the area gets redesignated, you have a maintenance plan, and again, remember the maintenance plan has got to project maintenance for at least 10 years after the date an area has been redesignated back to attainment. The thing that these three SIPs all have in common: mobile budgets and contingency measures. Mobile budgets. Now first I'm going to tell you what a mobile budget is. It's the amount of on-road emissions that are specifically identified in a control strategy plan. So that means in a rate of progress plan, an attainment demonstration, or a maintenance plan, that can be allowed to remain in the air after attainment, rate of progress, or maintenance has been demonstrated. These mobile budgets are used by metropolitan planning organizations to demonstrate transportation conformity. You are going to get a presentation from someone from our Office of Transportation and Air Quality from Ann Arbor, who's going to talk to you a great deal more about transportation conformity. But basically what transportation conformity is the new source review program for mobile sources and mobile projects. What it means is that the metropolitan planning organizations take a look at all of the mobile related projects that they want to build in the geographical area to ensure that the on-road mobile emissions will stay within the mobile budget. It's important to know this. In any given year, the tightest set of mobile budgets apply. Now the reason I have to say that for any given year, when you do mobile budgets, you can have mobile budgets for the near years of an attainment demonstration, rate of progress plan, or a maintenance plan, and you may have mobile budgets for the out years. But in any given year, the tightest set of mobile budgets applies. For example, a geographical area may have a rate of progress plan and a maintenance plan. They both have mobile budgets in them. Again, for that given year, the tightest set of budgets apply. What I'd actually like to do is draw a picture to show you what a mobile budget looks like. I'm going to actually attempt to draw for you in a diagram form what a mobile budget is. Mobile budgets are one of the most complicated things to think about when you're doing air quality planning. And many times you'll get even members of Congress, senators, who want to say, what's a mobile budget? Because obviously many of these transportation projects that have been approved for funding by DOT in their jurisdictions are very important to them. And remember, they have to be shown to conform to the state implementation plan's mobile budgets. So in an attempt to have to explain to elected officials what a mobile budget is, this is the best diagram I've been able to come up with. Basically, what I'm doing is I'm drawing 5 bars. And the first bar is labeled stationary sources. The next bar I'm going to label on-road mobile. The third bar I'm going to label off-road mobile, area sources, and biogenic sources. Now, in each one of these plans, we emission inventoried the base year inventory, meaning by a base year inventory, we inventoried the emissions of the criteria pollutant and its precursors for one of the 3 years of the original 3 years worth of data we used to determine whether the area was a non-attainment area or an attainment area. Where we found its design value to be non-attainment, the base year inventory is the annual emissions during one of those years. In other words, the emissions that were in the air that created the readings on the monitor such that the design value calculated to be non-attainment. So you had a certain level of stationary source emissions, a certain level of mobile on-road emissions, a certain level of mobile off-road emissions, a certain level of area source emissions, and a certain level, given the individual pollutant perhaps, of biogenic emissions. But we are obviously, and the state is going to develop requirements that reduce emissions from stationary sources. Those are those control strategies we talked about. So for example, if you were in an ozone non-attainment area, you're going to reduce VOC emissions. So you had the base level, and then you have the level, and I'll draw a dotted line, of the emissions after you've designed the attainment plan, the attainment demonstration, the rate of progress plan, or the maintenance plan. Same thing will be with a combination of state and federal measures to reduce on-road mobile emissions. You will have a lower than the baseline level of on-road mobile emissions. Same thing with off-road. There may be requirements to control emissions from off-road mobile sources, and that will result in a reduction in emissions from the base year. And then area source emissions, again, a combination of state and federal measures to reduce area source emissions. If they're from the state, they've been put in the SIP. The SIP can account for the federal area source measures. That reduces emissions. But if you take a look at this diagram, what you have after you demonstrate either in an attainment demonstration or a maintenance plan or a rate of progress plan, each of these levels in these bars below the dotted line is the amount of emissions that are allowed to stay in the air after you have produced the attainment demonstration, the rate of progress plan, or the maintenance plan. So this, and I'm circling the amount of on-road mobile emissions allowed to stay in the air after you've produced the reductions in emissions to demonstrate attainment, maintenance, or rate of progress. That's a mobile budget. As I told you, there were 2 things that these control strategy SIPs had in common. Again, control strategy SIPs being the rate of progress plan, sometimes called an RFP plan, reasonable further progress plan, the attainment demonstration, or the maintenance plan SIP revision that goes along with a redesignation request. In addition to all 3 of these types of SIPs having mobile budgets, they also have to have contingency measures. But the contingency measures for the attainment demonstration and ROP plans are a little bit different than the contingency measures in a maintenance plan, and I'll explain both. With regard to an attainment demonstration plan or a rate of progress plan, the contingency measures are measures that would automatically go into effect if progress or attainment is not met by a required date or by a required milestone date. Basically what these are additional reduction measures of the criteria pollutant or its precursors, such that you have additional reductions beyond what you deemed necessary for attainment and rate of progress. What's interesting about these, however, is that these contingency measures must be able to go into effect automatically, meaning no additional rulemaking by the state. They're already on the books by the state, and the way that they were written is such that they would automatically go into effect if an attainment date or a milestone date was missed. What's interesting, however, is that a state may choose to implement the contingency measures of an attainment demonstration plan or a rate of progress plan early. So even if they don't miss a milestone date, and even if they appear on track to achieve attainment or have achieved attainment, they may still implement the contingency measures. Whereas in a maintenance plan, now remember, this maintenance plan is the 10-year projected plan submitted by a state along with a redesignation request. So now, if the redesignation request has been approved and the maintenance plan has been approved, this area has been redesignated back to attainment. What the contingency measures are in a maintenance plan is an identified set of additional measures that would be adopted and implemented if the area were to exceed or violate the standard after it's been redesignated. Now, what's key here is contingency measures of a maintenance plan may not be implemented early. Now, let's figure out why this would be. You've redesignated an area to attainment. You thought everything was working, the plan you developed worked, the air got clean, all 5 criteria were satisfied from Section 107E, including the maintenance plan. It was approved, but there are triggers in the maintenance plan that would kick in the contingency measures. Obviously, if you implemented these additional reduction measures early and then violated, you'd have no additional measures to clear up the violation that just happened. So what you need to do is the contingency measures of a maintenance plan may not be implemented early. Those additional reductions have to happen or be available to happen because the area has either exceeded or violated the standard. This was determined by a court case. And it's interesting, the court case where this was decided involved a judgment by then a Pennsylvania federal judge named Justice Alito, who is now in the Supreme Court. So it's a pretty solid determination that the contingency measures of a maintenance plan, and for very logical reasons, may not be implemented early. You need to have something that will happen after the area violates to further reduce pollution. If you reduce the pollution before the violation, you've got nothing to kick into place once the violation occurs. Now, I want to say this. If the contingency measures don't work, then the area may be designated back to non-attainment. And so far, it's been my experience that our maintenance plans have tended to work. Where contingency measures were required, they were adopted by the state, put into place, and we saw a return to air quality that met the standard. Federal implementation plans, again, we talked about this a little bit earlier. They're promulgated and directly enforced by EPA until the SIP is approved. Now remember, what would have prompted a federal implementation plan? The most common reason it happens is because a state either failed to give us a required Part D SIP element, it gave us an incomplete Part D SIP element, or we had to disapprove it. Again, if the sanctions clocks go all the way to 24 months, that's when, before EPA gets the SIP element in from the state to approve, we're on the hook to promulgate a FIP. Now, we can sometimes have to promulgate a whole FIP, meaning the state didn't give us any of the elements and basically we're responsible for producing the entire attainment plan. That is extremely uncommon. What is much more common are things called partial FIPs. In other words, the state has given us most of the elements from Part D of the Clean Air Act, but one or more of them was missing, not complete, not submitted, or disapproved. And EPA promulgates only that missing element. We call it gap filling. Where there's a gap in the required elements of an attainment plan, usually a Part D requirement, EPA will promulgate it until, and the FIP will remain in place until the state does do the adoption, does submit it to EPA, and EPA approves it. I do want to hasten to say, though, because we're talking about state implementation plans in general, there can also be FIPs that are associated with attainment areas. In those cases, there's no sanctions involved. It simply means that EPA, either because of a lawsuit or because it was time to implement and we hadn't put out instructions for the state to do it, we sometimes promulgate a federal implementation plan, even for attainment areas, that remain in place until the state does its part, adopts a measure that would take the place of the FIP, submits it to us, and we approve it as part of the SIP. So not all FIPs carry sanctions. But a FIP for a mandatory Part D element, because the state did not give that to us, those are the kind of FIPs that are associated with the 179 sanctions. There are some other important topics and facts that anyone who does air quality planning should learn about and bear in mind. Findings, sanctions, and FIPs, I just basically touched on them in this presentation. You could do a whole presentation on just the order of sanctions rule, how findings are made, how sanctions are imposed, and how FIPs are both imposed and subsequently lifted. You can also talk about the need for submitting a complete SIP. And a complete SIP revision has to satisfy 40 CFR Part 51 Appendix V, and that's an italicized V, as well as Section 102 and 103 of the Clean Air Act. I can't tell you how many times a state has done all of the real yeoman work. I mean, it's been done, all the technical work has been done, the attainment demonstration looks great, the regulations look great, but because the submittal comes into EPA without satisfying all the bells, whistles, and administrative requirements of 40 CFR Part 51 Appendix V, EPA cannot approve it. Sometimes it's incomplete. So it's really necessary for the people in the state who are going to submit the actual SIP revisions to EPA understand what is meant by a complete SIP revision, and there are both administrative and technical requirements. There's something called e-docketing. Since the mid to late 90s, EPA has been doing what is called e-docketing. When EPA does rulemaking on a SIP, in other words, the state has submitted a SIP revision to us, EPA has to conduct rulemaking action, notice and comment rulemaking action. Generally, we do a notice of proposed rulemaking. We offer a 30-day public comment period on our decision to approve or disapprove a SIP, and then we do final rulemaking action. This used to be just something in the Federal Register, and if the public were interested, they'd either have to go to the state capitol and look at the SIP revision there, or come into the EPA regional office and look at the SIP revision in hard copy at the EPA office. All that changed. All SIP revisions are now put on a certain kind of PDF. They are loaded into an electronic docket, and any member of the public with any access to a PC or a Mac, be it their own or the library, they only need access to the internet. And if they can read the Federal Register online, no more having to go to the library if they have their own PC, they can see in every day the Federal Register is promulgated, it's online. They can see what happened that day. They can look in the table of contents, and if EPA took action, any EPA regional office took action on a SIP revision, it's listed. They can see the notice of proposed rulemaking, they can see how to submit comments, and they can submit comments electronically, by email, by fax. We have greatly increased the ability of people to participate in the federal rulemaking process. The e-docketing procedures are set up for the people with computers who deal with disabilities. A very strong push was instituted in the late 90s to open up the rulemaking process through e-docketing. But understanding e-docketing, if you're the person in the state that is going to submit the SIP, is important because the type of PDFs that these files have to come in on so we can load them up onto the system have to be in a certain format. There are certain other things to realize. When EPA headquarters promulgates a national environmental regulation, for example, those consumer products rules that I talked about, when EPA promulgates a national regulation for air pollution, for example, our implementation rules I talked about, the authority for EPA to promulgate that national regulation or that national rule is done under the authority of Section 301D of the Clean Air Act. However, when regional offices conduct rulemaking on SIP revisions, although our authority to make the decision to approve or disapprove flows out of the Clean Air Act, the actual statute that governs our rulemaking process is not the Clean Air Act. It's the Administrative Procedures Act, the APA, which is why when EPA is sued on a national rule, it goes into one kind of court. But if a citizen or a company or another state wants to sue EPA because it does not agree with the action taken on a SIP revision, that litigation is in the Court of Appeals. And there are understanding the rulemaking processes that available to EPA, understanding where litigation on SIP actions take place is important information for a state to have and will be covered in other presentations. Thank you. I'm going to give you my contact information. This is my email address and my phone number. If you have general questions on the requirements for state implementation plans or anything that I said today, please feel free to send me an email. If you can call me, but you're more likely to get an answer faster via email, I want to say this. If you have questions, however, on the specific requirements for a given non-attainment area and what, as a state, you need to submit to EPA for that criteria pollutant, for that given area, you need to contact your own EPA regional office to go over the requirements for a specific area for a specific SIP revision. But if it's a general question, I will try to help you out. Thank you very much. I hope today's information was useful.